Hey everyone, and welcome. You ever stop and think about what's actually going on under the hood when you're online? Well, today, we're diving into the unseen digital armor, all those security protocols that are working like 24/7 to keep our data safe. Let's pull back the curtain and see how it all works.
Okay, let's set the scene. You're at a coffee shop. You hop on their free Wi-Fi to maybe log into your work email. I mean, we've all been there, right? But did you ever really think about what's stopping the person at the table next to you from, peeking at everything you're doing? What is that invisible shield? That is exactly what we are going to break down today.
So, to make this all real, let's follow someone. Let's call her Alex. She's at that coffee shop and she needs to securely log into her work network. Now, on the surface, that sounds super simple, but her data is about to go on this wild, complex journey. We're going to follow it step by step.
Okay, first things first. Before Alex's data can go anywhere at all, her laptop has to get permission to even join the network. See, this isn't just about clicking connect and hoping for the best. It's more like a secure handshake, a whole process of proving you are who you say you are.
And that handshake? It's run by a framework called AAA. That stands for Authentication, Authorization, and Accounting. Just think of it like the network's bouncer, and it asks three really simple but crucial questions. First, authentication. All right, who are you really? Prove it. Then authorization. Okay, I see you're on the list, but what are you actually allowed to do in here? And finally, accounting. So what did you end up doing while you were connected? It's really the whole package for controlling access.
So for Alex, this whole handshake happens in just a few lightning-fast steps. First, her laptop uses a protocol called 802.x to ask for access. But, and this is the important part, the coffee shop's Wi-Fi router doesn't make the call. Nope, it passes her request on to a central server using a protocol called RADIUS. That server is like the head of security who checks the master guest list. Once it confirms Alex's ID, it sends the signal back. She's good, let her in. It all happens in a blink.
All right, Alex is in. She's on the coffee shop's Wi-Fi. But now comes the most dangerous part of the trip, sending her data across the wide-open public internet to get to her office. This is like trying to send a valuable package through a chaotic, crowded city. You can't just send that package out there naked, right? It needs protection.
The best way to think about this is the difference between a postcard and a sealed envelope. When you send data using old-school HTTP, it's just like a postcard. Anybody who gets their hands on it along the way can read the whole message. But with HTTPS, that little S stands for secure, it's like your message is inside a sealed, tamper-proof envelope. It's encrypted, so even if someone intercepts it, it's just a bunch of scrambled nonsense to them.
Now, building that armored tunnel is a total team effort. The protocol that really makes HTTPS work is called TLS. But since Alex is connecting to her whole work network, she's probably using a VPN. A VPN uses something like IPsec to create a secure tunnel for all of her traffic, not just her web browser. And there are other players in the background too, making sure she's actually talking to the right servers and not some imposter. It's like a whole security detail, all working together.
Success! Alex's encrypted data has made it safely across the internet. It's arrived at her company's network. But here's the thing about fortresses. Getting past the main gate is only half the battle. The security can't stop there. The inside of this digital fortress needs to be just as secure as the outside walls.
Think about it. Inside a network, you definitely don't want everyone to have access to everything. I mean, you wouldn't want the marketing intern accidentally stumbling into the top-secret finance department's files, would you? It's just like a real office building, where different departments are on different floors with their own keycard access. Well, networks do the exact same thing, but digitally. They use something called VLANs.
And yet, that technical term, VLAN, it just stands for Virtual Local Area Network. It's a really cool protocol that lets network admins take one single physical network and basically chop it up into multiple, isolated virtual ones. So when Alex connects, she's automatically put into the sales VLAN. Her traffic is totally separate from, say, the engineering VLAN. It's a super powerful way to control who can go where and to contain any problems if they pop up.
Okay, so we've got secure access, we've got internal walls, but how do you actually know if something bad is happening? You need eyes and ears everywhere. It boils down to a simple truth in security. You absolutely cannot protect what you cannot see.
So how do you get that visibility? Well, it mainly comes from three things. First, you've got to have logs of everything that's happening, and those are collected with a protocol called Syslog. Second, you need to understand the traffic flows, who's talking to who, and how much, and that's handled by things like NetFlow. And finally, you have to keep an eye on the health of all the gear itself, the routers, the switches, and that's what SNMP is for. You put all that together and you finally have a real-time map of everything that's going on.
Now, this next part, it's one of those things that sounds small but is absolutely critical. For any of that logging and monitoring to actually work, every single device on that network has to have the exact same time, right down to the millisecond. And that's the job of NTP, the Network Time Protocol. Why does this matter so much? Well, imagine trying to investigate a crime by looking at security camera footage where every camera has a different time. It'd be a total forensic nightmare. You'd have no idea what happened when. That's why this quote is so true. Without accurate time, your security logs are pretty much useless.
So we've followed Alex's data all the way from the coffee shop, across the internet, and deep inside the corporate network. But here's the twist. In our modern world, with cloud computing and so many people working remotely, that whole idea of a secure inside and a dangerous outside, well, that concept is basically crumbling. The perimeter is disappearing.
You see, the old security model was called castle and moat. The idea was to build a huge wall and a deep moat, your firewalls, and then just assume that anyone who made it inside the castle was trustworthy. But the problem is, if one bad guy gets in, they have free rein to cause chaos. The new model, Zero Trust, flips that whole idea on its head. Its motto is beautifully simple: never trust, always verify. It doesn't matter if you're inside or outside. Every single time you try to access something, you have to prove you have the right to be there.
And of course, this new way of thinking is powered by some really cool new tech. For example, ZTNA is replacing old VPNs. Instead of just giving you the keys to the entire castle, it gives you access to one specific app for one specific session after verifying you again. And then there's this huge shift called SASE. It basically takes security out of the central office and moves it into the cloud, delivering it as a service directly to users, wherever they are in the world.
So let's look back. From 802.1x and RADIUS at the coffee shop, to IPsec and TLS crossing the internet, to VLANs and Syslog inside the network, we followed the entire journey. And you can see, this isn't just a random soup of acronyms. They are a deeply connected, coordinated team, a relay race of digital guardians, each with a very specific job, all working together to protect Alex's data at every single step.
And that really leaves us with a huge question, doesn't it? As that traditional network perimeter dissolves, and as we move towards this zero-trust world where our users and our data are literally everywhere, it forces us to ask something fundamental. In a world with no inside and constant threats, what does security even mean anymore? It's not a place you're in, it's a constant state of verification. Well, that's something to chew on. Thanks for joining me on this journey.